Professor Pelton. This is Algebra 2, Chapter 5, Section 5, Function Operations. We're going to start off on page 2. This is part 2 of the video. Scroll down a little bit here. Okay, so this problem wants us to subtract the two functions, f minus g of x. So that's f minus g of x. So f is 3x cubed minus 2x squared plus 5 minus g, which is x cubed minus 3x squared plus 4x minus 2. We need parentheses because this is all of f minus all of g. If you don't put the parentheses, it only minus part of f and part of g, which doesn't make any sense. Okay, so we'll distribute the 1's now, and negative 1, so f minus g of x equals 3x cubed minus 2x squared plus 5 minus 1x cubed plus 3x squared minus 4x plus 2. Alright, then we can combine like terms and get f minus g of x. Alright, so we combine like terms, we'll get 2x cubed 1x squared minus 4x plus 7. Alright, so there's our final function for f minus g of x. Okay, so we need domain and range and a specific example. So we'll do the specific example first. So once specifically x is negative 2. So if we do f minus g of negative 2, we get 2 times negative 2 to the third plus 1 times negative 2 squared minus 4 times negative 2 plus 7. Okay, so simplified. F minus g of negative 2. Exponents come first. So that's 2 times negative 8 plus 1 times 4. Alright, after exponents comes multiply. So if we multiply, we get negative 16, positive 4, positive 8, positive 7, for a final answer of, that'd be what, 19 minus 16, 4, 3. So essentially, if we plug in negative 2, we get 3. So negative 2, 3 would be a coordinate on this particular graph. So the last thing now is the domain and range. So as we said in part 1, you don't think about what you can be, you think what you can't be. Because what you can be is an infinite number of things. You can't think that way. So you have to look at this problem and see, are there any denominators? Are there any even roots? Are there things that would restrict what I cannot plug in? Okay, well if I look at this problem, it's a cubic problem. I can cube, square, or multiply by x for any number. So there are no restrictions. There are no even roots or denominators. Thus, this can be negative infinity to infinity. Since there's no restriction on the input, there's also no restriction on the output. Okay. Also, if you think about it, this is a cubic, which looks like this anyway, so all cubics look like that. And it just goes forever in all directions. And we can prove that by looking at a calculator. And you can clearly see, it kind of looks like a cubic. It's a little off the graph, though. But we can change the window. And we'll change the settings. We'll go, need a little higher, looks like. I think this was fine. I think this is the problem right here. Negative 10, and we'll go to like 20 here. And hit OK. And you can clearly see it's a standard cubic, and it goes in all directions, up, down, left, and right, forever. Okay, pause the video and try the student problems for yourself. Okay, for the student problems, we want to do f plus g of x and f minus g of x. We want to do both. Okay, so we'll do f plus g on this side. So we get negative 2x to the 2/3 plus 7x to the 2/3. And over here we'll do f minus g of x. So negative 2x to the 2/3 minus 7x to the 2/3 for our functions of f plus g of x, since these are like terms. we're going to get 5x to the 2/3 for the plus function, and the minus function, f minus g of x, we're going to get negative 9x to the 2/3. Okay. Alright, so in both cases it wants domain and range and a specific example. So we'll do domain and range first. Okay, so domain and range. Domain and range. Okay, so we have to think, is there a restriction? Are there any denominators or even roots that I cannot plug in? Okay, well, I don't have any denominators here, so that's not going to eliminate anything. Also, I don't have any even roots, because this is really 5 third roots of x to the second power, correct? And this one is negative 9 third roots of x to the second power. Since it's a third root, that's an odd root, I can do both positives and negatives. There's no denominator, so there is no restriction. Okay? In both cases. However, the range, you have to plug in the domain to get the range. So if I plug in the domain, 5 third roots of negative infinity squared, and 5 third roots of infinity squared. Okay? If I plug those both in both cases, I get positive infinity, because if you square a negative, you get a positive. So in both cases, I get infinity. So this is going to go to infinity. However, the question now is, what is the smallest thing I can be? Since I can't go negative, what's the next number that's closest to negative? Well, that would be 0. That's the smallest I can be. That's the smallest number. Because if you plug in 0, it'll actually work. Because third roots of 0 is 0. Square root of 0 times 5 is still 0. Okay, and over here, same thing. If I plug in negative infinity, and I plug in positive infinity, okay, slightly different is going to happen here, though. Because in this case, I'm going to get infinity. In this case, I'm going to get infinity. Because essentially, it's infinity times 5 in both cases. Over here, that is not the case, because the square will force this to be positive in both cases. Okay. However, it's multiplied by a negative 9 in both cases. So a negative 9 times a positive is a negative infinity. So in both cases, I get negative infinity. So it doesn't look like I can get a positive number. So this is going to negative infinity. Okay, I can't get a positive number no matter what I do. So the question is, what is the biggest thing I can get? Well, again, same answer. The biggest thing I can get is 0. Okay, we can prove that to ourselves graphically in just a moment. Actually, we'll do that now. We have space down below to do the calculations. So let's look at a calculator and see visually what's actually going on. So the first one is 5x to the 2/3 power. And you can see it goes forever left and forever right, which is what we said for the domain, right? We said forever left and forever right, so that's negative infinity to infinity, that's our domain. Down, it can only go to 0, but it goes up forever, right? So that's our domain. So our range is 0 to infinity. Again, it's the bracket because you can be that. Okay, let's look at the other one now. So the other one, menu, graph, function was negative 9 times x to the 2/3 power. Okay, and that's the flipped graph. Because the reality is that negative 9 is making you go down no matter what you do. Okay. So as a result, it's still going forever. Whoops, move that here. It's going forever left and forever right as it peels off, right? So our domain is still negative infinity to infinity. However, it goes down forever for our range, and it still only goes up to 0. Because both of them always go least to greatest. Okay, let's do the last part now and plug in the specific examples. So for these specific examples, it wants us to plug in 8. So plug in 8 to both problems. So we want f plus g of 8 and f minus g of 8. That g didn't come out very well. We'll change that. There we go. Okay, so this is 5 times 8 to the 2/3, and this is negative 9 times 8 to the 2/3, which is really 5 third roots of 8 to the second power, or negative 9 third roots of 8 to the second power. Okay, so order of operations, grouping symbols first. The radical counts as a grouping symbol. The third root of 8 is 2, so that's 5 times 2 to the second power. Exponents come next, so it's 5 times 4, multiply comes last, so we get 20 in this specific example. In this specific example, again, parentheses first, so we get 2 squared, exponents last, second, so we get 4, and then multiply for negative 36. Okay, so it looks like in this example we get 8 comma 20 as one of the coordinates on the graph, and this one we get 8 comma negative 36 as one of the coordinates on those graphs that we made. That is the end of part 2.